To create our first routing curve, first we select the feature, routing curve. Then there's a number of options that we can use to create the points. We can either select from existing geometry, which I don't have here right now. I have an empty part studio. So in this case, I'm going to add points simply by dragging the axis of this manipulator with this option here, add point on axis drag. So I start by dragging the axis in any of the directions, and you'll see quickly that the curve is created. And we are creating a 3D curve, you can see here, as I rotate. It's as simple as that to create your first routing curve. The reference coordinate system for these points that we just created is the model origin, and that's because we didn't choose to supersede it with any selection up here in the curve reference part of the dialog. You can see here the red, green, and blue triad represents the direction of that reference coordinate system. Now I can choose a new reference coordinate system, perhaps to be a mate connector, and you'll see that when I select that using curve reference, that the entire curve is transformed up to that. The numbers of the offsets of the positions of those curves, the numbers do not change. The only thing that changed was the reference. So if I take away that reference and go back to the origin, you'll see how the curve follows that. That's the curve reference section in the routing curve user interface. To edit the position of any of the points that we created for this routing curve, I can simply select on the point itself and move it with the manipulator. Before we do that though, let me turn off this option that would add points for any drag operation that I do. Now that I've turned that off, I can drag the manipulator and you'll see how the point is moving and the curve is also moving as the update. Now this manipulator is interesting because I can control it in rotations as well as translations. So I can align the manipulator as necessary before making a translational move as such. The position of the triad for each point is stored with each point. You'll notice that if I choose the point up here, the triad is aligned to its original position, which is with the world coordinate system, because that is our reference system right now. If I go back to this point where I had moved the triad, I can reset it by using the Reset Triad button in the user interface. In addition to moving the triad in order to edit the position of the points, I can simply type in values here in the offsets section. I can put in some nice round numbers and have that position nicely controlled. Now remember, these are with respect to the reference coordinate system. I strongly suggest that you use this option to show the reference coordinate system using the red, green, blue triad, so that you can be sure that the moves you are making are with respect to that which you are expecting. Now, all of these points we created initially were with respect to the origin, the model origin, as our reference coordinate system. I could come back for any particular point, and instead of referencing the reference coordinate system here, I can override that, supersede it, by selecting the point reference area and choosing the new reference for that particular point. We'll see here now that that point is 0, 0, 0 offset from the mate connector. The result of doing this is that this point on the routing curve will always follow that mate connector's origin, even if the mate connector changes location. Let's try that. Let's finish the feature. We can see our curve. We can see the mate connector's position. Let's go back and edit the mate connector, perhaps make it a little bit higher in the Z direction, and you'll see how that edit causes the routing curve to completely follow through the mate connector's location as well. Let's try a different example in this new part studio. I have some sketches with some points. I have a sketch with some edges and some vertices. And I have 2 mate connectors. Let's create a new routing curve and start using some of these references for our curve. We'll start with the mate connector, a vertex, another vertex, 1 vertex, and another mate connector. You can see the 3D interpolated spline that we've created. If I click on any of the points, you'll see how their reference is actually referring to a vertex of sketch. In this case, it's referring to a mate connector. In this case, it's vertex of sketch again, and this last one, it's another mate connector. This curve will remain fully associative to the changes to those sketches. Let's have a look here. If I edit this sketch and move that vertex, you'll see how the routing curve updates. This way you can get parametric associative updates for your routing curve. There's more than one way to create these routing curves. In the first examples, I've been creating or selecting vertices in order to create the path or the points for my routing curve. Let me show you a couple more ways that we can do this. If you have a part like this, which of course has edges, or maybe a sketch, which has edges as well, we can use this to seed the creation of the points that we need for our routing curve. Let's try that. Let's create a routing curve, and up the top section here you'll see in the inputs group I can select edge. Here I can then select any edge and provide a number of samples that I'd like to make along that edge. Perhaps it's 22. Now when I hit the process button, I will create 22 points, which are the seeds or the point control points for my interpolated spline. If I finish that feature and hide that part and hide the sketch, you'll see the control point. You'll see this routing curve that I created with all of the control points along it. Now these are points just like any other points that we've created in using the previous method of either selecting or creating the points individually. I can select any one of them and I can edit their position. Now we have a full 3D interpolated spline that goes through these new points, including the displaced version of that point. Again, move the manipulator, move the point. One very interesting thing that we can do is rather than have the reference to all of these points be the same origin, we can change the reference for this point to be relative to the previous point in the chain. If I do that, you'll see the triad for the reference will shift onto that previous point. This is why I suggested you do show reference coordinate system so that we can be absolutely sure of the relativity between the points that you're editing. If I move this point, you'll see the 2 points move together. In this way, we can create kind of a constrained situation between the locations of any number of these points. An extra tip when you're using this edge processing, there's an option here which by default should be on, which is to overwrite points. Now the reason for this is that we might want to come back and reprocess the points that were there. So let's turn back the part, turn that on again. Choose the edge, and instead of having 22 points, let's go with 11 or 13. If I process this, then the original 22 points will be overwritten by the new 13 points. If you do not use this, you can end up with a somewhat confusing mess of points that you didn't intend. So my suggestion is to use the overwrite points by default. Now there's even another way that you can use to get points into the feature for which you can then pass the interpolated spline. Let's start another routing curve feature, and instead of using the vertex option and instead of using the edge option, we'll choose the third thing, which is the CSV file import. Now, you might have a CSV file already in your document, like I have here, or you can select one from another document, and it will be linked. So let's choose the CSV file. The next thing we need to do is choose the units for which the data in the CSV file was created. I'll choose inches here. And when I process that, you'll see that the points come in and the interpolated spline in this case is created straight away through those points. Of course, the reference system is still set. The reference coordinate system is still set to the default, which is the origin. And again, I can change that just by selecting some other reference point. In this case, this mate connector. And you'll see all of the points now transformed onto that reference system. I can use a different mate connector, put that one up the top as well. There we go. Now these points are just like any other points that we've created before. I can select and I can move. I can also add points using two different methods. I can add a point and then drag it. So now I've got these 2 points. I'm going to delete that one. I could also use the method here where I add point on axis drag. So that's an option that I would initiate. Then when I drag the axis, additional points are created. A couple of things to note. This is not changing the original CSV data. This is adding data to the inputs that we had processed through the CSV file import process. Secondly, I can always use undo or redo with this feature. The CSV file input and options and processing takes up a little bit of space in the user interface, so it might be convenient to collapse the group to let your focus return to the editing and the positions of the points down here. And just as before, we can create a relative to previous point kind of constraint. As we click on any point, there is this identification of the ID of the point. So we've got point number 9 and point number 10 right here. So for point number 10, I'm going to say make it relative, make the position of it relative to the previous point. You'll see how these offsets did change. And I can put in a nice round number. Like that. Now, when I select this point, any changes I make here will be relatively transmitted through to this point here. Before I do that, there's something I do need to point out. If you recall, we created this point using the add point on axis drag option. Some of these other points were not created using those options. Make sure to deselect that point before making any local edits, unless of course you intended to add new points. You can see here now I'm manipulating this point number 9, and point number 10, which is set relative to it, will always remain exactly 20 millimeters above this point, because that is what we'd set as its offset. Now the routing curve that we just created was still the interpolated spline, but it's a very simple matter to select Polyline instead, and it will turn this whole selection of points into the endpoints of line segments, or a polyline. You can see here we can flip between the interpolated spline and the polyline. And of course, editing these points is exactly the same as before. It will maintain those relations between the points. This point here we can move on its own. We can use the add point on axis drag option to add additional points as necessary. With the polyline, which is a very useful line to be type to be using for frames and maybe some rigid pipe routing. One of the options that's only available for polyline is a bend radius. So we could provide a default bend radius for all segments. Any particular edit could be made to override that bend radius, and perhaps we wanted a smaller bend radius of 2 in this location, or something a little bit even smaller, like 0, to have a sharp corner. That's the polyline option of the routing curve. I'll make the radius 0 again so that we have some nice sharp corners to show you this next example. Now you can see that some of these segments, and we call them segments here in the user interface, are no longer orthogonal with our reference coordinate system. We can do editing to the segments over here. We would simply select the segment we wish to edit, and a box showing the orthogonal components is shown. So I select the edges of the box representing the directions that we want to use to turn that original diagonal line. You can see if I undo that cyan colored line here was the original diagonal, and we're going to turn it into these 1, 2, 3 segments like that. Now the reference coordinate system happened to be set to be the same as the world coordinate system, but that didn't have to be true. We could have used a different coordinate system as our reference. We can also choose other coordinate systems here. Let's go back to point editing, and you'll see how the segments which were shown in the magenta color now become the lines of the polyline again. The final part of this feature to demonstrate is the keep points option. Up to this point, if we accept the feature, we end up with the curve, and that's all we have. There is an option to keep points, which will have additional point objects. These can be useful for measurement and other reference information that you might need in future, especially if you have used bend radii. Those points are at the virtual sharp between these segments. For the control point curve, you'll find the user interface is largely the same as the routing curve, with a few key differences you'll see with the degree, the elevation, and perhaps some other things that we'll get to later. But to create our first control point curve, let's do kind of like we did with our first routing curve and use the add point on axis drag. You'll see here that the degree currently is set to 3, so let's leave it to that. And as I start creating my first point, or my second point, the first point is here at the origin, you'll see a message that I need at least 4 control points for a spline of degree 3. Okay, let's go with that, and let's create our third point. Message is still here. When I create my fourth point, I create the curve, and the message goes away. So let's remove this add point and have a look at these 4 control points and the control point spline that we've just created. So I can manipulate these control points in the same methods that we had seen before with the routing curve. I can use the manipulator in a plane. I can reorient the manipulator to go in certain directions. I can look at the reference coordinate system, which is currently set to the world origin. And we have 4 control points and a degree 3 curve, which happens to be then a Bezier spline. If I move this to create a full 3D effect, you'll see the 3D spline in there. Now we have our control point curve. We can examine some of the options for editing even further. The first of that is the degree. Now the degree of the curve was set originally to be 3, and we have our 4 control points. Makes it a Bezier curve. We can elevate the degree, and what that's going to do is it's going to add control points as necessary to elevate the degree to 4 or perhaps 5. Notice that the shape of the curve has not changed. This is a mathematical fact that we can exploit. We can create an exactly the same shape by increasing or elevating the degree. If we decrease the degree and take control points away, we can't guarantee the shape. We'll try as much as we can and try as hard as we can to maintain the shape, but it's not mathematically possible to guarantee that shape change. Now, it's a topic for a further video, but if this was a generic NURBS curve rather than a specific Bezier curve, then the number of control points we're adding and taking away can be a little bit harder to predict. In the case of a Bezier curve like this, by increasing or elevating the degree by 1, we'll be adding 1 control point. Just note that for a generic NURBS curve that we will deal with later, that is not as easy to do. Easy to say, sorry. Right, now the reason we might want to elevate the degree of any of these curves is to provide additional handles or manipulating points that we can use to control the shape. We might not be able to get the exact shape had we just started with our 4 control points. Now that we've got 6 control points, we've got a little bit of extra local manipulation. And speaking of local shape changes, we can change the weight of any of these control points. So by default, the weight is set at 1 to start with, but we could increase that or decrease that. So you have the ability to see that shape change very quickly. If I increase the weight, the influence of this curve of this point over the curve's shape becomes much greater. Almost like a gravitational attraction to this point here. We get a very high number of weight. You can see that it starts to really kink strongly here. Now, if we use the curvature combs and curvature analysis tool, which is just a quick Shift-C shortcut away, you can see that the effect that the weight has is to obviously decrease the minimum radius there, but also to increase the curvature quite dramatically. As we get back to 1, this was our original curvature. In the previous example, I used the elevate and decrease buttons to rapidly make changes to this curve. An alternative, or a different use case in fact, is to just directly change the degree of a curve without changing the number of control points. Remember, when I elevated the degree, I was doing that by increasing the control points. By just specifying the degree, you'll see that the shape changes quite dramatically, but the number of control points has not changed. In doing this, what we have done is create a multispan curve rather than the Bezier curve that was originally there. Here's a simple but maybe practical example of where we would use a control point curve. I have some existing geometry and I'd like to create perhaps a loft or a boundary surface on this end, and I'd like some guide curves. If I try and use a 3D fit spline, I don't have enough control. Similarly, if I create a bridging curve, I don't quite have enough control without creating lots of additional geometry. The control or the guide curve I'm trying to create here is not planar, so I can't use a sketch. Now, this is the situation to use a control point curve. I'm going to select one or two, or let's start with these two selections for the vertices. And again, we've got this message saying we need 4 control points for a spline of degree 3. But I could override that and say I want a spline of degree 1, and for that 2 control points is going to be enough. Now I'll hide this reference coordinate system just for the moment so you can see we've created this degree 1 line between these two vertices. At this point I can elevate the degree maybe a couple of times. So I've got an additional 2 control points in here, and because I've got additional control points, I can start manipulating them in any of the directions that I like. So now I have full control, and I can keep adding and elevating the degree and adding control points to give me as enough control as I like to create the shape. Of course, it's always a good idea to use as fewer control points as possible to keep the curves as smooth as you possibly can. Just as in some of the routing curve examples, it's possible to set the relative to previous point option. So I'm going to have this point be relative to the one above it, and I'm going to then set these as 0 and maybe -10 as the offset. So if we looked at this from the top view, these points are exactly on top of each other, and I can just move the top point and have the 2 points update together. This is a particularly good option for when you want to maintain kind of a smooth curve, at least getting it right in the first position, and then you might want to do some additional tweaks later on. If we want to do a little bit more subtle shape change to this curve, but we want to keep it as a degree 3 Bezier curve with these 4 control points, then of course we can use our weighting control we talked about last time. So I select a control point and maybe provide a heavier weighting for that control point. And you can see here that the shape of the curve has changed, and of course the curvature has changed quite a bit as well. But we haven't had to add additional control points. In doing so, we've created a rational curve. And indeed, this whole feature here, the control point curve feature that we've got, is a generic NURBS modeler, so a non-uniform rational B-spline curve modeler. The Bezier curve is a special case, and whether it's rational or non-rational is just also a special case. Let's have a look at a slightly different scenario for the control point curve. Here I've got a couple of sketches. These are the things in blue. They're splines. And the orange curve is a bridging curve that I've created with a G3 connection at each end. So it's going to be a nice smooth connection. We can have a look at the connectivity there. All right, you can see the connection is very smooth. Similar to the routing curve, or in fact identical to the routing curve, when we create a control point curve, we don't just have to digitize vertices. We can actually take edges as input. So let's do that for a control point curve here. For example, we could use this original sketch. See, it's a planar sketch. And I just select it and say process it. It will extract the control points of that original sketch. And again, I can use these control points to manipulate and create, in fact, a new curve. The black curve that is being created is a new curve. The blue original sketch remains. Now, if I do the same extraction but use the bridging curve instead and process that, you'll see the 1, 2, 3, 4, 5, 6, 7, 8 control points which were created as part of this G3, G3 bridging curve, or a degree 7 bridging curve. We've processed that, and just like we did with that example before, once we've processed something, or once we have the curves, we can elevate the degree, perhaps, any number of times. So let's go to, well, we can go up to a degree 15 curve, but when I say any number, 15 is the maximum there. Once we have the curve degree that we require, and still we have a Bezier curve here, we can manipulate this curve. We have lots of control points here, but we have a degree 13 curve. Now, an interesting fact is that if we specifically override the degree and say make this degree 5 again, we've kept all of these control points, but we've set the degree to 5. In doing so, we've created a multispan curve. There's an additional option in the control point curve, so rather than making a multispan curve, we can make piecewise Bezier curve representation of this. If I use that option, you come back and see now that when I select, I'm actually looking at the pieces, each of which is a degree 5 Bezier curve. And look at the control point grid. Maybe it's a little hard to see on this section. Maybe I'll choose one of these over here as one that's a little bit easier to see. Yes. So now we have 1, 2, 3, 4, 5, 6 control points, making that piece a Bezier curve of degree 5. It's an option, a simple option on the end of that feature to make piecewise Beziers instead of a single span, a multi-span curve. In this last example for control point curve, I've got a situation which occurs quite commonly. That is, when you project curves onto other geometry, or in this case, I've projected 2 curves or 2 sketch curves to create the third curve. Interesting things can happen. So this curve is a pretty simple spline, and this other blue curve is another simple spline created in sketches. The curve here in orange was created using the projected curve option between 2 sketches. If we examine this curve that we created a little bit closer, and I'm using a tool that is a custom feature that I created to do the interrogation of the curve, you'll see that it is a degree 3 spline with 63 control points. That is a very, very large number of control points for such a small, simple looking curve. Now, the impact of having a very complicated, mathematically curve at least, is quite going to be felt downstream when you use this curve as the basis of, say, a profile for a loft or a guide for a sweep. Whenever you do those sorts of downstream applications or usages of this curve, it might not behave as nicely as you hope. And up to this point, there's not a lot you could do to avoid that other than change your construction method to try and avoid the situation entirely. What you can do now, though, is a very, very interesting and powerful thing with the control point curve. So just as before, we're going to use an edge as the input, and I'm going to choose that projected edge as the input. And I could process it right now and extract all 63 control points, and that's not going to be any help to us. What I do want to do instead is to reapproximate it. Now there's this approximation tool built in, which will allow us to approximate this spline input edge at a given target degree with a given number of control points that we want to use. It could be whatever number that you like, up to 1,000, and at a given tolerance. So the tolerance is going to do some interesting things for us. So let's set it to be 0.1 millimeters and process that. And you'll see immediately it's created a curve with only the 13 control points, I think 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 in this case. So with 12 control points, it got close enough to meet the tolerance target that we set it. All right. We could even try a looser tolerance. Let's try something really loose and try and use only 6 control points to do that. And let's pick the edge and process it. And you'll see here, in fact, it has been able to do that with 1, 2, 3, 4, 5, 6 control points. Now you can see that the original orange curve and the black curve, which we just created, are slightly different. In fact, their tangencies or their slopes or derivatives are different at the end. We can try and control that or enforce that with these options. Keep start derivative and keep end derivative. But for this simple example, what I wanted to show you is how much we could reduce the mathematics in this curve. And in fact, by creating a degree 5 curve with only 6 control points, we've made this into a Bezier curve again. Now, this black curve that we just created is going to be a much nicer candidate for use in sweeping edge or providing the edge for a boundary surface or any number of different downstream usages. The point being, when you're creating primary surfaces, you want to use as clean a curve as possible and try to never use the edge of a trim or a projection, because they do the same thing as I just showed you in creating a very busy, complicated curve. So the control point curve is going to be an incredibly powerful tool to address these types of situations.